Every minute, over 500 hours of video are being uploaded to the YouTube platform. And if you do the math, you would need 82 straight years to watch all the content pushed onto YouTube servers over the span of just one day. And YouTube is just one site. So how big is the rest of the internet? It's estimated by Statista that current worldwide data center capacity is around 2,000 exabytes. And that's a lot of storage space. But these days, it's also estimated that the world produces about 2.5 exabytes or 2.5 million terabytes of data every single day. Now, not all of that ends up on the internet, but it's still clear that it's not enough to keep up with our needs indefinitely, especially as the trend these days is to just throw everything into the cloud instead of actually bothering to delete anything. And this growth in data is not expected to slow down anytime soon. A recent study by IDC projects that in 2025, just 5 years from now, the data sphere, which includes everything from Amazon's cloud servers to your cell phone, will be up to over 160,000 exabytes of data, with about 40% of that needing to be saved somewhere. That works out to about 64 billion terabytes worth of medical records, memes, and tech videos that will need a server to call home. So it's not surprising then that big tech is trying to get more data centers built as quickly as they can, and new technologies like heat-assisted magnetic recording or HAMR, which you can learn more about up here, are being developed to increase the capacity of traditional hard drives. In fact, Seagate is aiming to use HAMR to push out a 100 terabyte hard drive sometime around the middle of this decade. But if we can't churn out high-capacity hard drives and build enough shiny new data centers to accommodate our thirst for data, not to mention find energy sources to power them all, what are the alternatives other than just purging some of that information? Well, one option is to use algorithms to compress the data. But short of some kind of big breakthrough in middle-out compression, we're not anticipating huge advancements there. So perhaps more interesting is the research that's being conducted on entirely new forms of storage. Instead of using magnetic particles, for example, scientists are looking at storage solutions that take up far less physical space, such as DNA-based storage, where each base pair represents a bit, or nanomaterials, like a glass disc that can hold 360 terabytes, yet is no bigger than a coin. However, even if we find a way to encode data using subatomic particles, in other words, we find the most space-efficient way to store data that the laws of physics will allow, we would still run out of space in a few centuries if we keep generating digital data at the rate that we are right now.